Hello students, I am Dr. Rajaram Dhok from Savitribai Phule Pune University affiliated Agricultural Development Trust Shardabai Pawar Mahila College Shardanagar Baramati. Let's start. Ionic Solids Lecture 8, Lattice Energy or Crystal Energy. In this lecture, we see about the lattice or crystal energy. So what is lattice energy? So this lattice energy is defined. It is the amount of energy released when the requisite number of gaseous cation and anions they are condensed and there is formation of crystal. So for the formation of 1 mole of compounds, when such type of gaseous cations and anions are condensed, then there is formation of such type of compounds and that is energy produced in that is called as lattice energy or crystal energy. This lattice energy is also defined in some other words. Lattice energy is the energy change when 1 mole of crystal is formed from its component or component ions in the gaseous state. Means different component ions in their gaseous state when they combines, and at that time the energy required, that is also called as crystal energy or lattice energy. So we take one example that Na plus gas, this ion when combines with Cl minus gas, then it produces NaCl solid, and at that time U is equal to delta H and that is equal to minus 755 kilojoule mole raised to minus 1. Means here symbol U is used for the lattice energy, and in this case when sodium ion in the gaseous state and chlorine ion in the gaseous state when combines, they are condensed, then there is formation of NaCl solid or NaCl crystal, and at that time minus 755 kilojoule mole raised to minus 1 energy is released. So here energy or delta H value is minus. This negative sign suggests there is a release of energy or there is exothermic reaction. So when Na plus gas and Cl minus gas when combines, then solid NaCl is formed and minus 755 kilojoule per mole energy is released. Now we see the again some other definitions, that is the lattice energy. So lattice energy is also defined as the energy required to separate or to break a mole of solid substance into gaseous ion and bring them to rest at infinity. Means this reaction is given in the opposite direction, that NaCl solid when undergoes breaking, then for the breaking of that NaCl, the energy required, that is called as lattice energy. And when that NaCl is break, then it gives Na plus gas and Cl minus gas. At that time delta H is plus 755 kilojoule mole raised to minus 1. So this energy is opposite to the combination of Na plus and Cl minus. Here delta H is positive value, and this lattice energy of solid NaCl has a positive sign, means it is endothermic reaction. So the stability of ionic solid depends upon the value of its lattice energy. So when we see the different crystals, then its crystal energy, its stability is important. So crystal energy depends upon their lattice energy. When that energy is more, then stability of that crystal is high. So such type of stability we can correlate with each other. For the calculation of this lattice energy, there are two methods. One is the theoretical method, and that method is developed by Born and Lande, and so that method is called as Bornland Equation method. Second method is experimental method, and that method is developed by Born and Haber, and so that method has given name Born-Haber cycle. So this method is explained in the form of cycle. So that is called as Born-Haber cycle. Now we see the Bornland equation. So Bornland equation is given. In that equation, Born and Lande studied for the formation of lattice energy, and he developed one equation. That equation is U is equal to minus Na square Z plus Z minus divided by R into, in the bracket, 1 minus 1 by N. So in this case, we see the notation U is equal to lattice energy of that ionic solid. Capital N means Avogadro's number. And we know that Avogadro's number is constant value. Its value is 6.023 into 10 raised to 23 per mole. R, that is distance between cation and anion, or we say that is the internuclear distance. Z plus and Z minus, these symbols are used for the charges of cation and anion. So how many charge on the cation and anion, that is shown by the Z plus and Z minus. So Z plus means cationic charge, Z minus means anionic charge. Then A is one constant, that is Madelung constant, and which depends upon the geometry of crystal lattice. Then capital N, this is one constant that is called as Born exponent. And value of this Born exponent, that is calculated, and for the atomic number 10 or neon configuration, value of that is near the 10. So we see the second method, Born-Haber cycle. So this Born-Haber cycle is developed in 1919, and this Born-Haber cycle is given in the different steps or in the cyclic form. So there are 5 steps. So we see the different steps or methods. So firstly, we see the method 1, that is the direct combination, and second method means stepwise combination. So direct method means in that there is direct combination of solid sodium metal and gaseous chlorine, and it forms sodium chloride. So in this direct reaction, we write Na gas plus 1 half Cl2 gas, it gives NaCl, that is solid state. And in that case, delta HF, that is equal to minus 410.86 kilojoule mole raised to minus 1. So here, this is given the one step reaction or direct combination. But actually, here, these reactions are carried out in different steps. And so we see the second method, that is stepwise combination. So in this stepwise combination method, here reactants, that is sodium, which is in the solid state, and chlorine, which is in the gaseous state, are first vaporized, and they are converted into gaseous ion. So gaseous atoms. Again, that atoms, they are converted into ionic form. Then that ions combines with each other in the gaseous state, and it forms solid crystal. So such type of different steps are necessary, and for the detailed study, we see these steps in different cycle or in the cyclic form. And so that is called as Born-Haber cycle. So we see the first step. So in the first step, we see the sublimation of sodium. So when we take 1 mole of the solid sodium, that is Na solid, then they can be converted into the gaseous sodium. So how they are changed? So that solid is converted into directly gas, that is called as sublimation. And energy produced or energy absorbed at the time of sublimation, that is called as sublimation energy. So we carry out the sublimation of sodium, and for that purpose that energy is Na is equal to plus 108.7 kilojoule mole raised to minus 1. So when that sodium solid, when converted into sodium gas, at that time energy is absorbed, and that energy is called as Sna. Now second step, dissociation of chlorine molecule. So chlorine is generally in the molecular form. So in molecular form they are stable, but when they are stable then they are not reactive. So firstly we dissociate, we break chlorine molecules, and that chlorine molecule is converted into chlorine atom. So half mole of the chlorine molecule, they are dissociated and it forms 1 mole of chlorine atom. So we write here reaction 1/2 Cl2 gas. When they are dissociated, they can be converted into Cl gas. So when they are undergoes dissociation, then that energy is called as dissociation energy. And we write how many energy here absorbed. So 1/2 dCl2 is equal to plus 120.9 kilojoules mole raised to minus 1. This energy is absorbed, and that is called as dissociation energy of chlorine molecule. Then third step, formation of sodium ion. So here in the first step, sodium metal is produced in the gaseous state, but we require sodium ion. So for the conversion of atom into the ion, that energy is required, and that is called as ionization energy. So 1 mole of gaseous sodium atom, they are converted to sodium ion, and they are produced by removal of 1 electron of the sodium atom from their valence shell. So when 1 electron is removed, then it forms Na plus ion in the gaseous state. At that time, that energy is Ina, and that energy is plus 493.8 kilojoules mole raised to minus 1. So in this reaction, the energy is also absorbed, and this energy, that is called as ionization energy, that is Ina. Then fourth step, formation of chlorine ion. So we have seen in the second step, there is formation of chlorine atom, and that is in the gaseous state. But that atom is converted into ion, and for that purpose, 1 electron is gained by the chlorine atom. So electron which is given out by the gaseous sodium ions, they are taken by the gaseous chlorine atoms, and that gaseous chlorine atom, they are converted into chlorine ion. So here this energy, that is called as electron affinity, and so we write ECl is equal to minus 379.5 kilojoule mole raised to minus 1. And this energy is released, and that energy is called as electron affinity of chlorine, that is ECl. Now in the second step and fourth step, that sodium and chlorine, they are formed in the gaseous ionic state. Now these both are combined, and there is formation of ionic solid Na plus and Cl minus, they combines and forms NaCl solid. So this gaseous sodium and chlorine ions, which is just we have seen in the step 3 and 4, they combines and gives solid NaCl or sodium chloride crystal. So in this, energy is released in this process, and by definition it is called lattice energy, U, and that is represented as UNaCl. So how that UNaCl is formed? For that purpose, we write that different reaction Na solid gives Na plus, that SNA is equal to plus 108.7 kilojoule per mole energy. One half Cl2 gas gives Cl gas. One half DCl2 is equal to plus 120.9 kilojoule mole raised to minus 1. Na gas gives Na plus gas, and that is the INA is equal to plus 493.8 kilojoules mole raised to minus 1. Then fourth reaction, Cl gas, it gains 1 electron and forms Cl minus ions, and that energy is ECl, and that is equal to minus 379.5 kilojoules mole raised to minus 1. And Na plus gas plus Cl minus gas, it gives NaCl solid. So this NaCl solid when formed, then at that time energy formed, that is delta HF, is equal to minus 40410.86 kilojoule mole raised to minus. So this energy is produced. Now we see this all the 5 steps in the cycle, and that is already we seen. So this is the first step or direct reaction, Na solid plus 1 half Cl2 gas, it gives NaCl solid. Now first step, that is the heat of sublimation, that Na solid is converted to Na gas. Na gas is converted to Na plus ion gas, that is the ionization energy. Then by heat of dissociation, chlorine molecule is converted to the chlorine atom in the gaseous state. Then chlorine atom is converted to chlorine ion in the gaseous state. That energy is electron affinity. Now this Na plus gas and Cl minus gas, they combines and forms NaCl, and that is the lattice energy. So in this way, in the cyclic form, we can show these 5 reactions, and that is called as Born-Haber cycle. Now we see here heat of formation of this NaCl, how it is calculated. So heat of formation is equal to combination of that all energies, that is SNA plus 1 half DCl2 plus INA plus ECl plus UNaCl. And we can add this all the values. By adding that all values, we can calculate the UNaCl. So we separate that UNaCl at one side, and other parts or other points we rearrange, and from that we get UNaCl is equal to minus 754.76 kilojoule mole raised to minus. So here this energy has minus sign. So that is the lattice energy value, suggests that energy is liberated in this process. So at the time of formation of NaCl, energy is liberated. Now we see calculation of that lattice energy in other example, that is sodium fluoride, by using that Born-Haber cycle. So in that Born-Haber cycle for the sodium fluoride, here sodium has same reaction, only fluorine is different, and we see how it is produced. So in that heat of sublimation, Na solid is converted to Na gas, and energy same, that is we have seen in NaCl, that is SNA is equal to plus 108.7 kilojoule mole raised to minus. Then heat of dissociation of fluorine gas, that is converted into fluorine atom. So 1 half DF2, that is plus 153 kilojoule mole raised to minus. Then third reaction is similar to the NaCl example, that is INA is equal to plus 493.8 kilojoule mole raised to minus. Then fourth step is electron affinity. Chlorine gas is converted to chlorine ion, and that energy is electron affinity for F, and that value is minus 332.6 kilojoule mole raised to minus. Now that all the values are added, and by adding that we can calculate the here UNAF. So that UNAF value we can calculate, and by rearrangement you share here rearrangement we get UNAF is equal to minus 991.9 kilojoule mole raised to minus 1. So in the formation of sodium fluoride crystal, the energy is also liberated, and that liberated energy is minus 991.9 kilojoules. And when we compare that energy with NaCl, then for the formation of NaF, energy required is more. And so NaF crystal is more stable than NaCl crystal. Uses of Born-Haber cycle. When we use the Born-Haber cycle for the determination of lattice energy, then this Born-Haber cycle is also useful for other purposes. That we use the general equation that delta HF is equal to S plus 1 half D plus I plus E plus U. So this equation is used to determine the different properties like electron affinity. This Born-Haber cycle is useful for analyzing and correcting the stability of various ionic compounds. Again, this Born-Haber cycle that is also used, and they are known the nature of bonding in the compound. Then it is used to calculate the energy of hydration of ions and the energy of ligands in the complexes. It is also used to check on the calculated energies. So these are the some uses of Born-Haber cycle.